Have you ever stopped to wonder how we can actually teach a machine to think? I don't just mean calculate things, but to genuinely learn, to see patterns, and to make its own decisions. You know, it's one of the biggest questions in all of technology, and the story of how we answered it began over 60 years ago with an idea that was, well, it was remarkably simple, but absolutely revolutionary.
Okay, so let's really dive into this. At its absolute core, the problem is all about sorting things. I mean, how does your email client figure out what's spam and what isn't? Or how can a computer learn to tell the difference between a picture of an apple and a picture of an orange? You need some kind of mechanism, right? Something that can look at a ton of examples and just figure out the rules for itself. This was the exact challenge the very first learning machine was built to solve.
And look, an idea like this never just appears out of thin air. It was a whole journey. It really kicked off back in 1943 with this theoretical spark, the idea that you could use networks, kind of like brain cells, to actually compute things. Then in 49, another huge piece of the puzzle fell into place, the idea that these networks could learn on their own. All of this groundwork finally led to 1958, when a psychologist named Frank Rosenblatt introduced the world to the perceptron. This was the first practical model for what we call supervised learning, which is really just a fancy way of saying you teach the machine by showing it examples and telling it the right answers, kind of like using flashcards with a student.
So, in this explainer, we are going to completely break down this incredible invention. We're going to start with what it is, then we'll look at the anatomy of its simple brain cell. After that, we'll get into the really cool part, how it learns from its own mistakes. We'll also have to look at its critical breaking point, when it all goes wrong. And finally, we'll wrap up by understanding its powerful and foundational legacy.
So, let's start with its place in history. You see, the perceptron holds a really special title. It was the very first algorithmically described neural network. This wasn't just some abstract theory anymore. It was a concrete step-by-step recipe for machine learning that would go on to inspire an entire generation of scientists and engineers. So what is a perceptron, really? Well, put simply, it's a classifier. Its only job is to look at data and sort it into two different groups. But, and this is the big but, it only works if those two groups are what we call linearly separable. Just think of it like this. If you can take a pen and draw one single straight line between all the apples and all the oranges on a table, the perceptron can find that line. If you can't, well, that's where the trouble starts. All right, let's pop the hood and see how this thing actually works. The best way to think about a perceptron is as a single, super simple artificial neuron. It's like one brain cell.
Okay, so let's break down what's going on here. On the one side, you've got your inputs. That's just the raw data coming in. Now, each one of those inputs gets a weight, which you can think of as an importance dial. It turns the influence of that input up or down. Then you have the bias. The bias is a really clever trick that gives the model a bit of flexibility. It's like a shifter that helps nudge the final decision line into just the right spot. The perceptron takes all this in, crunches the numbers, and spits out a super simple answer. It's either class 1 or it's class 2. That's it.
Now that final decision is all based on where the data point falls in relation to something we call the decision boundary. And for a simple problem with just two features, like points on a graph, this boundary is literally just a straight line. It is the perceptron's line in the sand. If a data point lands on one side, it's class 1. If it's on the other, it's class 2. Simple as that. So, the billion-dollar question, right? How in the world does it find the right line in the sand? Well, this is where the magic really happens. The perceptron learns through a process that is just beautiful in its simplicity, trial and error. It literally learns by correcting its own mistakes.
The process is this really elegant loop. First, it gets an input and makes a guess, a prediction. Then it checks. Was I right or was I wrong? If it was wrong, it makes a tiny adjustment to its importance styles, those weights and the bias, to nudge that decision line just a little bit closer to where it should be. And then it just does it again and again and again. With every single mistake, it gets a little bit smarter. And hey, this isn't just some wishful thinking. There's actual math to back it up. It's called the Perceptron convergence theorem, and it's a powerful guarantee. It says that if a line that separates the two groups actually exists, the algorithm is guaranteed to find it. It's not going to get stuck searching forever. It will find a solution. But what happens when a separating line doesn't exist? This very question leads us directly to the perceptron's single, fatal flaw. We're about to see the exact point where this brilliant little learning machine completely and utterly breaks down. And this slide just illustrates the problem perfectly. Take a look at the data on the left. See how you've got two nice, clean clusters of dots? You could easily draw a single straight line right between them. The perceptron loves this stuff.
Now, look at the data on the right. See how the dots are all intertwined? No matter where you try to draw one straight line, you're always going to have the wrong dots on either side. This is the perceptron's absolute nightmare.
To really see this in action, researchers came up with a classic test using two crescent-shaped clusters of data. They call it the double moon problem. In the first test, the moons are separated by just a little bit of a gap. And the result? It's a flawless victory. The perceptron figures it out in just 3 passes and draws a perfect line, classifying all 2,000 test points without a single mistake.
But then, they push the moons together so they just barely overlap, making the problem non-linearly separable. And what we see here is a catastrophic failure. The learning algorithm never settles down, it just fluctuates forever, constantly shifting the line back and forth, desperately trying to find a solution that just doesn't exist. The final line just slices right through both groups.
And the final result is an error rate of 9.3%. What that means is that out of 2,000 data points, 186 were put in the wrong category. All because the data wasn't linearly separable. The perceptron was fundamentally, mathematically incapable of solving the problem. And this wasn't just some small bug, it was a critical, show-stopping flaw.
So you might be thinking, okay, if it was so flawed, why are we still talking about it today? And that's a great question. Because the thing is, despite this massive failure, the perceptron's legacy is absolutely immense. Understanding why this flawed masterpiece still matters so much is the key to understanding the entire history of AI.
Well, in 1969, 2 AI pioneers, Marvin Minsky and Seymour Papert, published a whole book that mathematically laid out all of the perceptron's limitations. But they went even further. They basically suggested that even if you stacked these things together into more complex networks, the whole approach would be, in their words, sterile. And this critique was so devastatingly effective that it helped kick off a period we now call the AI winter, where funding and interest in this whole field just dried up for years.
But you know what? History proved them wrong. Because the perceptron, for all its limitations, gave us the essential blueprint. It was the first supervised learning algorithm. It proved, once and for all, that a machine could actually learn from data. It gave us the core idea of learning by correcting your mistakes. And maybe most importantly, it became the foundational building block, the single Lego brick that all of modern complex AI is built on today. Every single neural network, from the one that powers your phone to the massive models changing our world, owes its existence to the simple, elegant, and foundational ideas first laid out in the perceptron.
It's just a powerful reminder, isn't it, that even ideas with really deep flaws can become the necessary first steps toward a technological revolution. And it leaves us with a pretty fascinating question to chew on. What simple, maybe even flawed ideas that are being kicked around today are quietly laying the foundation for the next piece of world-changing technology?